So a very, very good morning to all the participants attending this FDP. ATAL has given a great idea of such faculty development programs and considering the trust areas in which the research is going to be done in the future times. One of this trust is artificial intelligence. So I'll be taking two sessions, this one and the next one, and I'll be covering some aspects of AI, big data, ML, DS. What are the differences between those? I would really request you to please mute your mic. Please keep your mics on muted mode. Thank you so much. But still I can see some of the people that their mics are not muted. Please mute your mics. If you have any doubts, any questions at any point of time, you can put it onto the chat box. My chat box is always open, so if you have any doubts, that can be cleared there and then. So please don't put your mic on. You can put it into your chat box, whatever questions you want to ask. So starting with the first concept, that is AI, artificial intelligence. If I ask you what is intelligence, so what will be your answer for it? Intelligence is something which is an added thing that you get apart from your technical knowledge or any other type of knowledge. So there are two things basically. Something you learn from the books. So you read a book. Suppose you are reading something about Taj Mahal. So you started reading the book of Taj Mahal, and then you came to know, okay, it is in Agra. It was built by Shah Jahan. It was built in so and so AD, and different details about the monument. So that is that you have attained from reading a book. Correct. Now, if I ask you, that is on which part of the road you should walk, so you will say you should always walk on the left hand side, because that is you have been learned and you have been taught in the schools and you have seen your parents doing it, so you come to know that okay, we have to always move towards the left hand side of the road. But whenever you leave your house and when you are actually traveling, when you are 15, 20 years old, are you going to learn it again and again, and are you going to read it again? That is, okay, I have to move on to the left, I have moved on to the left. No, it's something that you have already learned. And you don't have to reiterate it again and again and again. But secondly, there are certain things that you do out of your intelligence. Okay, so suppose if a person comes and talks to you in a language or in an accent which is very much related to Bihar, so you have at once will say, okay, do you come from Bihar? You have a Bihari accent. Or if you talk to a person who is speaking in a language which you don't know, but it resembles very much to a South Indian language, so you will at once you will come to know, okay, you belong to the southern part of the country. Probably you will not be able to identify between Malayalam, Telugu and Kannada as I will also not be able to. But definitely I will come to know that, okay, you belong to the southern part of the country. I have been not taught for this. I have not been taught for this, but I do know that what is the type of the language which is spoken in the different parts of the country. I don't know Uriya. But then if somebody speaks, you will be able to identify it. I don't know Bengali. So this is something which is intelligence, which comes to you automatically. So it is not you have learned, you have learned in the books out of it. It comes naturally to you people. So human beings are intelligent naturally. Human beings are intelligent naturally because intelligence comes to them naturally. You are able to do certain things which even you can't explain that how you are doing it. If I want a machine, I still can hear a lot of noise. Can you please mute your mic? I'll again request all of you to please mute your mic.
Deepthi agar start idu share irikkan
I don't have the right of mute all at the present because since I am not the host, I again request all of you to please mute your mics. It is giving a lot of disturbance. And also request all of you to please switch off your videos as well. Videos take a lot of bandwidth and then it will create a problem for all. Thank you so much. So we were talking about natural intelligence. Now, if I want a machine also to behave in the same way as we do. Now, as I told you, we have some natural intelligence. And I want my machine also to have intelligence, but of course it cannot be natural. It has to be artificial. So this is nothing but artificial intelligence. And what we are actually trying to do, we are trying to make the machine behave as what we do. Behave means walking, talking, responding, all these things comes a part of AI. So we do a lot of things which even we can't explain that how do we do it. As I told you, I am able to decipher between Oya, Bengali and South Indian languages. But of course, I am not able to tell you that how am I doing it. I don't know these languages, but still I can decipher between all the three. Correct. So there are certain things which you cannot explain how do you do it. I'll be talking about some more examples onto this, like how we are doing it in the later point of the slides. But at this point, it is necessary to understand what is actually AI, artificial intelligence, when we are making a machine behave as humans artificially. Okay, so we are programming the machine in such a way. So it comprises of two words, as I told you, artificial and intelligence. And it is something which is made by the human or natural thing. So intelligence is not bookish. You cannot attain intelligence. I'll give you another example. Like suppose if you are teaching a small child and you teach him A, B, C, D and so on. Yes, you will definitely get your PPTs, Sonal ma'am. You will get the PPTs at the end of the presentation. I will share it with Biju sir. And Biju sir will share it with all the participants. So please don't worry about that. So artificial refers to something which is not done naturally. And I give you an example, like there is a small child of 3 years of age, and you teach him A, B, C, and D. Okay, and you give the phonetics as A says B says B, C says K, and D says D. Correct. Now, as and when you teach E to the person, he himself says, okay, E means E. Okay, yeah, F means F. He's able to do it on his own. Please mute your mics. If the kid is able to say F says F, then that is intelligence. Because he was not told that. The kid was not taught about it like F says F. But he was able to decipher from the rest of the A, B, C, D and E. He was able to identify, okay, F says F. So this is intelligence. On the basis of certain factors, on the basis of certain cases, you are predicting what is going to happen in the future. Or you are predicting certain things on the basis of your past, or you are learning something on the basis of the previous things. This is all intelligence. And we are trying to make a machine also behave to perform in the same way. Okay? So, AI is a branch of computer science, of course. It is used to do the certain computations and behave as humans. Now, IBM comes with a concept of saying that artificial intelligence is nothing but augmented intelligence. I'll tell you why. What happened was, when the people were talking about AI, some people started saying that, okay, AI, since it is behaving like humans, so it may happen that in the near future, the humans are getting replaced by machines. So there was a long debate that went off and said that, okay, since machines are also behaving like humans, so it may happen that in due course of time, the machines replace the human beings, and whatever is being done by the humans at the present would be done by the machines in the future. So then there is a threat to the jobs, threat to the work humans are doing. Correct. So there may be some possibilities down the line, like the humans are not getting jobs, but their work is being done by the robots, by the humanoid robots. So IBM came to the concept and said, okay, this is not artificial intelligence, but this is augmented intelligence. Now, what is the meaning of augmentation? Augmentation says that is what adding something to existing things. You were already intelligent, and I'm adding to your intelligence. That is augmented intelligence. So it said that I'm not replacing any human being, but what I'm trying to do is I'm adding more functionalities, I'm adding more intelligence to the human being so that he is able to perform certain actions more, you can say, easily and more efficiently. So I give you an example. Like if I say I make an automated car. You must have heard about this also. Automated cars. But these automated cars are not going to replace the human beings. What are they going to do is only have certain functionalities so that it is able to tell the person who is driving that, okay, there is a traffic which is going on at the end, or a truck is coming at a very high speed, please reduce your speed, or you need to take a left turn for your destination, or there is a car which is coming at a very high grade speed from the back, so you should move on to the left hand side. So this is something which is added to your driving. I'm not saying that you are not going to drive anymore. You will be driving, but there would be an assistance to you. So you have been augmented with more intelligence. So it's not replacing the human beings, but it is basically adding to their intelligence. So it says human intelligence and augmented intelligence, that is how you are going to increase the efficiency of the human beings with the help of an AI solution. So you are providing certain things, certain solutions, certain algorithms, certain protocols, certain algorithms, so that you are able to add on to your existing intelligence. So AI says it is augmented. Augmented means you are adding something more to what is already there. You are adding to something which is more already there. Augmented. Artificial intelligence can be considered to be of two types. One is narrow and the other one is general. So if you see this, there is still a very, very long way to go for a general artificial intelligence. We are still on narrow AI only. Humans, I'll tell you, are very, very intelligent. You cannot compare humans with any of the machines. They are uncomparable, and still so much of robots have been made. Americans have done so much of research onto these humanoid robots, but still a long way has to go for this. I'll tell you how. You ask me, where is Taj Mahal? I'll tell you it is in Agra. You ask me, where is Statue of Liberty? I'll tell you it is in New York. Okay? Now you ask me, what was the introducing movie of Dilip Kumar? I'll tell you it is Jwar Bhata. Now if you ask me that who was the hero in Dilwale Dulhaniya Le Jayenge, I'll tell you it is Shah Rukh Khan. Correct? Now if you ask me what is evaporation, I will be able to tell you what is evaporation. That is heating the water, and whatever the vapors are coming is known as evaporation. Okay, if you ask me condensation, I'll tell you what is condensation. So see the diverse fields that you have asked. You have asked me geography, I answered the question. You asked me about Bollywood, I was able to answer your question. You asked me about history. I was able. You asked me that who was Akbar. I will be able to tell you that Akbar was a great king. He had 9 ratnas, and etc. 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 So you ask me any field, I can answer you the question. Firstly, so this is something bookish knowledge that I have of different domains. What's next? If you ask me that is what is the name of your uncle, I will tell you. You ask me who is Renu or who is Shrinu, I can give you the complete link of all this. That is okay. Daughters, and so on. So I have this knowledge also. And then you ask me that is okay, what did you eat yesterday? I will tell you what I ate. Okay, I eat so and so things. So humans have a wide knowledge. And you can also ask me the question that where did you go when you were 5 years old? I would be able to tell you where did I go and with whom did I go and what were the experiences of that trip. So all these things is there in our brain. Okay, and we are so intelligent to retrieve the things. If you ask me that is okay, let's go to Coimbatore, I'll say yes, we should go because I went there when I was 10 years old and I had a lovely time there. And then I again went last year and I saw Shivji statue. I went to that place and it was really beautiful. I will be definitely going there. Now you ask me, let's go to Mussoorie. I'll say no, Mussoorie is not so nice because it is a hill station and it is 35 kilometers from Dehradun and so on. So what are you basically asking me? My experiences, and I have learned from those experiences. What is the learning? I didn't like Mussoorie because it has so and so things. I liked Coimbatore a lot because it has so and so things. So this is I have learned from the experiences. So and I have learned from a vast experience. I have experience of science, of history, of geography, of Bollywood, of Hollywood, all the things I have. But machines cannot behave in this way. Machines are always domain specific. You can make a humanoid robot behaving in a particular domain. Like you saw the picture robot from Rajnikant, robot, and there was again 2.0. So that is still not possible. Even US has not done that. Nobody has done that. It's still not possible to have a machine which is very much resembling to a human being and it is performing all the operations as what humans do. Still not done. That is something general intelligence, and we are general intelligence, and we have still not come to that point. We are at narrow intelligence only, which is domain specific. I can make a smart speaker, I can make a self-driving car, I can make a web search, and so on, because these are related to a particular domain. So as I mentioned, we are still a long way to go. We are at narrow AI only, not even to general AI or super AI is long beyond. I can make one thing. I can make a robot who can play chess, and this is very much greater than the humans. He can defeat human beings. He can play so well that humans are not even close to that. That can be done, but that is domain specific. If you ask that robot to play Ludo, he will not be able to do it. If you ask that robot to play Monopoly, no, he can only play chess. Okay?
അതല്ല എന്റെ ഓഡിയോ മാത്രം ഓഫ് ആവുന്നില്ല.
Please mute yourself. Now, since all of you are engineers, so we always try to get a solution to all these things. We try to get a theoretical foundation on that. So Alan Turing was a great scientist and a mathematician in 1950s, and he said that there is a curtain, and on the backside of the curtain there is a machine and a human being. And there is a software which is made, which is telling that this answer is coming from a human being or from a machine. So if you ask a question, what is addition of 2 and 2, the addition of 2 and 20, so the answer would be 22. And the software or person here is not able to identify that whether the answer is coming from a machine or the answer is coming from a human being. Correct? Again, he asked another question like, where is Niagara Fall? Where is Niagara Fall? So an answer came as USA in Niagara in USA basically. So again, the person was confused that the answer has come from a person or from a computer. So this was Turing test, and it was built, the Turing test was done to prove that computers are really very intelligent and they are behaving in the same way as humans do. I go one step ahead on this and say, okay, if I ask him the question as 20 plus 2, I don't know who gave the answer. In today's world, this was 1950s, in which they were trying to tell that, okay, computers are very intelligent and they are all behaving the same way as humans. That was 1950s. Now, if I'm talking about 2020, in my opinion, it's my opinion, you will not get there in the books. So it's my opinion in saying that if I ask 20 plus 2, I am not able to decide that who gave me the answer. Then I asked 20 plus 40, again I got 60 and I was confused who gave the answer. Now, if I asked 2,30,456 multiplied by 6,477 and I get an answer. If the person is not Shakuntala Devi and I get an answer, so of course I will come to know that, okay, the answer is from the computer and not from the human being. Because a normal human being, if not Shakuntala Devi, a normal human being cannot answer this question. So, now the Turing test has failed because the computer is going to give me certain answers which humans cannot give. Correct? So, I believe that if you're trying to replicate a human being, then you should replicate in all the respects. Whatever answers a human can give, the same answers the machine should also be able to give. If human cannot give the answer of 2,30,456 multiplied by 6,000, then 6,482, then I shouldn't be giving this answer from a computer. But it's really tough. It's really tough making the computer not answer the question which he already knows. It's tough. So we were at this slide, we were discussing that how humanly you can think and what makes artificial intelligence different from the rest, saying that it is scalable. If you are having a database of 1 GB, then it is, and you are processing a 1 GB of data, then it should be able to process 2 GB of data as well. This is scalable. That is, as and when your data increases, your processing power is automatically in line with it. Automated insight extraction. Insights extraction means that is, you are finding out certain hidden patterns in your data and you are able to extract those hidden patterns from structured as well as unstructured data. Now, what is structured and unstructured means is that is, if you have a normal Excel sheet, a normal Excel sheet will have columns and it will have particular rows. So you have such type of data. This is known as a structured data because in this case you can find out the summation, the mean, and you can process this data very easily by simple numerical formulas. So this is known as a structured data. But what about images? What about videos? These such types of data which cannot be structured in rows and columns format are known as unstructured data. Images and videos cannot be converted into a rows and columns format. So this is known as unstructured data. So image process talks about both types of data. It's not that only if you have Excel sheet then only you can process it. If you have image data set also, it can be processed. Probably in the due course of time in your workshop, you will see hands-on on image data set, on sound data set also, video data set, and so on. So you can have any type of data, images or videos, and accordingly you have to process it. Now, since I am short of time, probably I'll switch on to a little. Yeah, please go ahead with the question. I'm not able to hear you.
I'm audible?
Yes.
Yes, madam. How to manage this kind of structure, semi-structured and unstructured data? It is required to configure or dump this kind of data using the big data Hadoop or any other.
Yes, ma'am. This is a question that should be asked in the first day, and on the last day you will get the answer to this question of this workshop. That's what I told. That is, in your hands-on, you will see that how this unstructured data is handled. Probably machine learning doesn't deal with structured data of Excel sheets and so on. Even if it deals with Excel sheets, then that Excel sheet will have so much of data that cannot be dealt normally.
Yes.
So we always try to deal with unstructured data because which is not possible to be done by normal ways that we have been doing till now. Okay, so we do handle the videos and images through machine learning. I'm not sure which language would be discussed in the lab sessions, but you can do it with Python, you can do it with R, some part of it through MATLAB also. But generally, we do coding of machine learning and how to do it. Any other question?
Thank you.
Okay.
No, thank you so much.
Thank you. So now, since my time has decreased, I'll quickly take up big data because I wanted to give you a link between big data, machine learning, data science, and artificial intelligence. You must have already heard about the word big data. So as the name suggests, the data is big. When I say big, it is in a lot of GBs. Lot of GBs form this data. And as what Dhara ma'am also asked the question, like we generally go for unstructured data in such cases to handle this big data in a normal, in an efficient way, in fact. So earlier when the data was, when I'm talking about in 1986, the data was only 1% digital. But as and when the years progressed in 2007, 94% of data was digital. And as what Tejas ma'am was also saying, that is nowadays we have gone 100% digital, almost 100% digital. You would be surprised that from past 3 months I have not gone to the ATM at all. There was no need of cash. The only cash that was required was to give to the maids. All the shops are accepting digital cash, all the petrol pumps, anywhere. All the groceries, I order groceries from Amazon or from Paytm or from Flipkart. So I'm ordering everything online. Everything has gone digital, and from past 3 months, there was no use of going to the ATM to take out hard cash. Because hard cash was only required for the maids. They don't accept digital cash. So now, after pandemic, in such times when everything has gone digital, there is a huge hue and cry for managing digital data. I'm also handling my please mute your mic. I'm also handling a project from Nagpur Police, and their major concern was that in these times when everything has gone digital, cyber crime is going to be a very, very big problem to be handled. Now thieves don't exist on roads. They are not going to, very few, you will find very few cases of thieves snatching your chain or snatching your purse. Now they have moved on to one level ahead and they are going for snatching your digital cash. So cyber crimes have come into picture, and the police department of all the cities are really very, very tense to how to handle this cyber crime. Because now the stealing is only in form of stealing the digital cash. Correct. So again, there is a need of handling that big data. And in due course of time, all of the researchers are moving on to the same field in which how you can handle the digital data. So big data is 94% of it, and you need to collect, store, research onto it. If you see the analysis, after the analysis, you are able to combine the data a little bit, and then you can make your decisions on the basis of that data. Is the data going to increase, decrease, and accordingly you can take certain decisions. There are basically 4 V's of big data: volume, variety, velocity, and veracity. And probably you must have heard these 4 words earlier also in a number of slides, a number of webinars, and all of them are talking about these V's. Somewhere you will find 5 V's, somewhere you will find 3 V's, but I believe that there are only 3 V's of big data: volume, variety, and velocity. Now, as and when I am speaking with you, and if suppose I want this entire recording, entire lecture to be recorded. I want this entire lecture to be recorded. With this, I get reminded of that probably Viju sir will need to record this session. Recording is in progress. Okay, so recording is getting done. So if this entire lecture is getting recorded, so you see we started from 9:15 and probably we'll finish it off at 12:45. So at such a long duration of somewhere around 3.5 hours, this 3.5 hours of video recording is to be saved. So see the volume. Volume when I say, because videos take a lot of data. Videos is nothing but a series of images. So if one image is taking somewhere around 3 MB or 4 MB of data, and in 1 second, you may have somewhere around at least 10 images, at least in 1 second. And in 1 minute, you will have somewhere around 180 to 150 images. Correct. And if you say about in 60 minutes, so in 60 minutes, it will be 60 into 150 images. And all this is taking 3 MB each. So it is nothing but 60 into 150 into 4 MBs. This much of data it is there. 60 into 150 into 4 MBs. That is for 1 hour. And if you are going for 3.5 hours, then you probably have to multiply everything with 60 into 150 into 4 into 3.5 MB. This much of data is there. So it's somewhere around 10 GB of data. See the volume. And it is only on half-day session, then half-day session again. And this will go on till 5 days. So if you multiply this with 10, so that would be the complete data for this workshop. And now if I try to apply some natural language processing onto this and convert my speech into text. So imagine what amount of data needs to be processed. It's a huge data that needs to be processed and get converted into video to text, or you can say speech to text. That is volume. Variety. I am showing certain slides to you, and probably some of the people would be showing some hands-on to you with a Google Colab or Jupyter Notebook or Anaconda or something like that. So they will be showing you some codes, and you have to write those codes. So that would be text involved. Correct. And I may also, in just another 5 minutes, I'll be showing you a video. So that video is also combined, images are also there, slides are also there, and text is also there. So see the variety of data you have. And you are supposed to process all type of data. You need to process your images, you need to process your text, you need to process your videos. So much of things need to be processed. That is variety. And velocity is, as I have told you, that every minute, every second, suppose I am speaking some 3 words, and every minute I am speaking somewhere around 180 words. So at which velocity I am speaking, you have to process all this. And as human beings, you are so intelligent. You are able to process it at one go. You are listening from past 9:15, approximately 9:30. It's already 2 hours, and from past 2 hours, you are listening everything. You are understanding it in your brains, and you are trying to process it also. So see your capabilities. You are processing a huge volume of data, huge variety of data, and huge velocity of data. So you are actually processing big data. Correct. And if I want the machine also to do it, so it's nothing but AI, artificial intelligence. So this is structured and unstructured data. To just give you a brief description about what is the difference between all this, I'll show you a video that will make the things more clear since I don't have much time. Now, when you say knowledge and insights, so you generally talk about the patterns, the meanings, the analysis you do on the existing data. It talks about extracting the knowledge. If I ask you what is the difference between data, information, and knowledge, so it would be like if I say 20 apples, this is data. It has no meaning to it. It's only 20 apples. What should I do with this 20 apples? Nothing. If I say I am eating an apple a day, then this has a meaning. So it says, okay, this is information. If data has a meaning, it is information. I eat an apple a day. What is knowledge now? Knowledge is combination of your information along with your database. So database says those people who eat an apple a day have very few chances of going to the doctor because an apple a day keeps doctors away. Correct? So what was there in your database? An apple a day keeps doctors away. It was combined with information. What was information? I am eating an apple a day. What was the conclusion? The analysis, the result, or extracting the knowledge. What was the insight that you took out? The insight was, since an apple a day keeps doctors away, and since I am eating an apple a day, so there are very few chances of me going to a doctor. Correct? So I am trying to find out a pattern in my data, extract the knowledge. I'm not talking about information or data. I'm extracting the knowledge. So that which has a meaningful information along with the combination of your database. And then you come up with a pattern. What will be the pattern? I am not going to the doctor. My family is not going to the doctor. My neighbors are not going to the doctor. Or there is some X person from Indore is not going to the doctor. There is some Y person from Thrissur who's not going to the doctor. And then you relate these three and say what is common in all three. That is, they are not visiting the doctor. Or if you say about the corona analysis, what is the reason that some of the cities have very less corona and some of the cities have a huge corona? In Nagpur, if you see, I am currently at Nagpur. So if you see at Nagpur, since till August, it was very, very small. Till August, it was 200, 300, and now it has become 2,000 every day. So what was the reason for it? This is analysis. What is the reason that now patients are coming on with 2,000 a day, 1,700 a day? And recoveries have also increased, of course, it is more than 50%. But what is the reason that it has gone to 2,000 when it was only 200 or 100 till August? Till 15th of August, it was just in hundreds of 70 patients or 20 patients or 30 patients every day. But now it has really submerged a lot, and now it is 2,000 a day. So now you come up with the analysis. Why so? That is data science. So now you got a picture. Data science may use machine learning algorithms for its analysis. So now you get a complete picture. AI and data sciences is not a subset of one another. They are absolutely different, and in fact, they are not completely different, but one is using the other. So data science involves AI methods to be used. AI methods need to involve certain data science statistical tools to come up with certain preferences, analysis, and so on. So if you ask me about this, so if you say in this form is, you can say this is AI, this is data science, this is AI. Akhilesh, sir, can you please mute your mic? And then you have ML, and you have deep learning. Okay, so let me write the terms now. This is nothing but AI, this is data science, this is ML, and this is deep learning. So data science may involve, if you see this, this intersection, so data science may involve deep learning, machine learning, and AI techniques to do the analysis. And AI is not a subset of DS, or neither DS is a subset of AI. That is data science. Data science and data analysis are used interchangeably. There is not a huge difference between these two. So these two are used interchangeably. So data science and data analysis and artificial intelligence, they are linked to each other, and data science may use the techniques of AI, ML, and DL to do the analysis. Clear? So this is what I was talking about, AI, ML, and DL. And you can see this is data science. I'm skipping this part because I need to talk about the analysis a little bit. Yeah. So if you see, there are 4 types of analysis: descriptive analysis, diagnostic analysis, predictive analysis, and prescriptive analysis. So these 4 types of analysis are done, and you can use these 4 types of words in your research papers also. Like suppose if you are going for only analysis, you are not going for any predictions or something, then you can say I'm going for a descriptive analysis, or you are going for a diagnostic analysis of so and so data. Suppose the data is corona data. So I can say predictive analysis of corona data, or prescriptive analysis of corona data, and so on. What is the difference between all 4? Descriptive and diagnostic are descriptive and diagnostic are past. What happened in the future? In the past. What happened in the past? So diagnostic said, why is it happening? And descriptive said, what is happening? So why and what are answered by the question. Descriptive and diagnostic, these are 2 from the past tense. What happened? Why did it happen? Okay. And what are the 2 questions which are asked for the future? What is going to happen? And what are the measures that I should take so that I can continue with it or avoid it? If something good is happening, I want to continue the same. If something bad is happening, I would like to stop it there and then. Okay, so descriptive analysis, what's happening? Diagnostic analysis, why did it happen? Predictive analysis, what is going to happen? And prescriptive analysis, what are the different measures that we can take to stop it? So if I have an example of this, so if you want to use it in the corona data set, applications of data sciences and corona 19, is healthcare. You can do the analysis on the basis of healthcare. How the number of patients are increasing? Why did it increase? What was the status in August? What was the status in July? What was the status in June? This is a descriptive analysis. Diagnostic analysis, as I gave you an example in Nagpur, the cases are going on increasing at a very high speed. So why did it happen? That is diagnostic analysis. Predictive analysis is in September it is going on to really a very bad state. Since every day 2,000 patients are coming, so in September it is going on to be a more worse. This is predictive analysis. And prescriptive can be, okay, to stop this, lockdown is required. From tomorrow onwards, there would be a lockdown. This is what government also did. So this is from government and management. The government has to take care of certain measures so that these things can be predicted, prescribed, described, and diagnosed. Correct. So government is taking certain measures and educational also took those measures. So AICTE came in and pitched it and said, okay, this is going to happen in the future as well. They took a predictive analysis of that. And prescriptive analysis was, okay, why not have online FDPs? Because in the future it is going to be repeated. The people are not able to join the classes. The people will not be able to join the colleges. So why not have a online FDP? This is what prescriptive analysis. What were the measures that you took for your predictive analysis? Okay. So, any questions if you want to ask? Any questions before we start with machine learning? I hope you have understood what we have discussed till now. Received only 2 replies out of 165 participants. 3, 4 replies.
Well taken. Understood.
Okay. Thank you. Great. So if you have any questions, you can put on the chat box. I'll wait for another 2 minutes for any questions to be there on the basis of big data, data analysis. Sakshi ma'am, I'll share the PPT and the video itself, so don't worry about the link. I'll share the PPTs, don't worry. I'll share the PPTs, I'll share the video with Biju sir, and he would be sharing it with you all. Anjali ma'am, that's what I told. The difference between AI and ML is AI is a superset and ML is a subset of it. So you cannot have any ML without AI. You have to have AI with ML. ML is just a subset of AI because as we AI is making the machines intelligent. That is making the machines do what humans want to do. And for this, you need to apply machine learning technologies, machine learning algorithms. New trends in AI is new trends in ML. There are things which are not ML, like you can say NLP, natural language processing. You can solve NLP without ML also and with ML also. There are certain things that you can do only with AI methods in NLP. And if the data becomes very huge, if the data becomes of GBs, then you have to apply ML techniques onto that. So there are many things which you can do just by applying AI methods. Like A-star is the searching algorithm. You don't need ML for it, but it's an AI technique. Got it, Anjali ma'am? So there are many things in which you don't need ML.
Madam, which programming language is best suited for writing code on algorithm for MLN?
Yeah, that's what I told. R or Python. We use R or Python programming language, and probably in your hands-on sessions also you will be taught one of them.
Okay, ma'am. Taken.
Yes, Abhishek sir, there is Google Colab is an online free software which you can use to have Python programming, and it's a cloud that is given to you. Let me show you once. Let me show you that.
But what is mean by data profiling? What is it?
So if you click on Google Colab, this is Google Colab is a cloud which is given by Google, and this is an online tool which you can use to write programs. Now, since it is an online tool, you can access many of the data sets, and you don't have to have your data sets onto your own desktop. Because many a times we face that problem that our desktops and laptops are all of old configuration, and we don't have that much of RAM. Because for machine learning algorithms, the RAM should be very high. RAM should be at least more than 4 GB or 6 GB of data. So it's not possible to change your laptop, of course. So what we do is we do it online. So Google Colab is one of the cloud that has been given by Google, and you can have your Python programs run on that. I'll show you one of them which I already have. Like I create a program for COVID analysis. So I had my data set of COVID onto my own machine, and I was able to do the programming onto that. So I was able to read the data, describe the data, and then actually come up with certain graphs, the visualization techniques. I was able to plot the graphs and do the diagnostic analysis. As I told you, diagnostic analysis, descriptive analysis, in fact, not diagnostic, descriptive analysis and predictive analysis also, because I'm trying to predict what is going to happen. If you see this here, X new. So I'm trying to give you some different dates. These are dates, 91, 92, 93 are dates which are in encoded format, because we cannot use strings in analysis. We have to convert them into proper numbers for analysis. So for analysis, I have converted these dates into numbers. So if suppose I want to find out that possibly what can be the possible number of COVID patients in Nagpur on 17th of September. 3 days down the line, on 17th of September, what can be the possible number of corona patients in Nagpur? Correct. So I take the data, like I have the data here. I can execute the code. Just give me 2 minutes so that I can upload the data set. Is that what you do? So if you see, I have uploaded the data set and it will come on the left hand side as covid.csv file. And I have given some particular dates. So I want to find out that this covid.csv is the data set which gives you the number of corona patients on different dates. I can show you the data also. Yeah. So this is the data set which says that on which countries, this is a list of countries, this is a list of latitudes and longitudes, and on which date, what were the number of confirmed cases, what were the number of deaths, and what were the number of recoveries. Correct. So suppose if I want to search for India, I want to search for India. So on 23rd of January, there weren't any cases. If I move a little forward and see on again 24th of January, on 6th of April, there were 4,778 cases. So this is nothing but descriptive analysis. When I'm trying to tell you what happened, I'm not going for diagnostic analysis, but I'm going for descriptive analysis in which I'm telling you what happened, and then accordingly I can make a graph of it. That is, what were the number of patients, confirmed cases, deaths, and recoveries. So 375 people recovered from corona, out of which 136 patients died, and these were the number of confirmed cases. Now suppose I have the data set for 6th of April. I want to predict it of 21st of April. Suppose I want to predict for 21st of April. So I tried my code, I trained my model and predicted it. That is predictive analysis. And then to check it, I can do it from this data set only. 22nd of just hold on. So on 17th of April, this was the data. Let me come to 21st. On 21st of April, this was the data. So one is the figure that I took it from my program, and one is this data. And then I can differentiate between the two. That what is the error in my model and in this. And this is exactly what we do in machine learning. When we try to find out, train the model and then evaluate the model, is that what we do. The model on the basis of what is the result that I am getting and what was my actual result. So we'll see that in a short while, that what are the different steps involved in machine learning. But this is actually what we do. So I have given you the dates. Suppose this is one of them is 21st of April, and then I'm trying to plot the graph for this. So by mu, I'm getting it like this. What is the predictions of y? These are the predictions. I can plot a graph also for this. Correct. This you would be doing it in a due course of time. In the entire workshop, there are many hands-on sessions, as I could see from the schedule. And in this hands-on sessions, you would be actually taking a data set, doing the diagnostic analysis and descriptive analysis, and then coming up with the predictive analysis. Okay. So going back to machine learning. Machine learning, as I have already told you a small description saying that machine learning is a subset of artificial intelligence. You can see this machine learning should be inside AI. Why is it shown in this form? Because there was one question, Anjali ma'am asked that question, that what are the things which are not ML? So that is what it is. Robotics is not completely ML. There are certain algorithms which are applied by AI, and some of the things are done through ML. Natural language processing, as I gave you an example. So first of all, what is the difference between machine learning and traditional programming? What makes it two different? Traditional programming will always give you a data and program as an input. Suppose I have a program saying, I have written a program in C++, suppose. I say int a is equal to 20, int b is equal to 23. And then I say int c is equal to a plus b, simple. And I'll say c out c. I've written this 4 line of code. Correct? Now these 4 lines of code, what are the inputs for this program, for this input for the system? The input for the system was A, B, C, and the program. This complete program. This program was given as an input to the system. These 3 data members was given as an input to the system. What was the output of the program? The output for the program was, of course, 43, because it was able to add 2 numbers and give you the answer. Now what if I give you something like this? You to write an operator here. Pardon? I want you to write an operator here so that I am able to get the answer as 43. What should be an operator for 20 and 23 to get 43? All of you will say, I need to have a plus here. So basically, what was the input to the system? The input to the system was the data. The data was 20, 23. I gave the output as the data or as the input to the system. What was the output? 43. Now I am asking you what should be the program to get 43. This is machine learning. Machine learning will always ask you what should be the program to get the desired output. Correct. What should be the program to get my desired output? So what is an input to the system? The data, and the output you give it as an input, and you actually get what is the program as an output. Correct? So that is what makes it different from traditional programming. And since engineers, we all to have three things: P, T, and E. What is the performance? What is the task? And what is my experience? When I was telling you about AI, I told you that I need to learn from my experiences. Then only I would say that, okay, I am behaving as humans do. What do the humans do? They learn from their past experiences so that they don't repeat any mistakes in the future. They don't want to repeat the mistakes. They don't want to do something which gave some problems to it. So that they want to do something which should not be a mistake, but it should be a sense of good respect. Correct? So they always learn from their past experiences. E. They do some task, that is the objective. What are you supposed to do? Objective T. And P, the performance. So let's take an example. Playing chess. I want to play chess. This is my task. Objective. What am I supposed to do? I want to play chess. But performance would be the number of times I won upon the total number of times I played. Correct? So I won twice and I played somewhere around 4 games. So in 4 games I won 2. So what is my performance? 50%. 50% is my performance. I was able to win in 50% of the games. Another task can be recognition of the faces. My task is to recognize the face. Percentage of faces, I saw some 20 faces, and out of that I was able to recognize 15 faces. This is my performance. What is my E? That is experience. In the previous case, what was my experience? How to play chess, firstly. Secondly, it will also involve the experiences, in the sense, last time I played chess and I put my horse in front of my queen and I lost. So I should not do it in future. I was playing chess last time and the elephant was taken away, and then I was also trying to put my horse under problem. I should not be doing this. Correct? So this is you are learning from your past experiences. What is the database? What is the experience in recognition of faces? The database of faces, in fact. So there is a database of 100 faces. Let me know how many of you can identify. Another task can be driving on a 4-lane way. So this is my task. I want to drive self-driving car. What is P? The number of kilometers I was able to drive without any accidents. And what is my experience? Maybe the Google Maps. Google Maps is my experience. Or I should not follow this route because there are many potholes. Or I should not follow this route because there's a lot of traffic. I will not go from this. I will go from there. This is experience. Let's start a poll. Can I do that? Because I wanted to ask a question from you all. I think it is available on the post. Anyways, just answer this question and put your answer in the chat box. I'll give you 2 minutes of time to think over. What should be the T? I'm supposed to mark a mail as spam or not on the basis of how I did earlier. So what is my task? Is it either A, B, C or D? Okay, I got 2 answers. So I'm getting variable answers, but most of the people are saying it as A. So yes, A is the right answer. This is actually T. This is T. Because what is my task? I am supposed to classify an email whether it is a spam or not. This is my task. What is this? Watching you label as a spam or not, this is my experience. And what is the number of times that I correctly said that okay, it is a spam, this is my performance. Because till now we were talking about that this is to be done, but how it is to be done? Being an engineer, we will always talk about the mathematical formula for it. How actually we are going to do it. So this is that mathematical formula, PET. So if you know this PET, then it will be easy for you to get a model and then evaluate that model. So we use machine learning in a number of ways. We do face recognition, and we do it in those cases in which humans can't explain their expertise. This is what I was talking about. I am able to walk on the left hand side and I don't know how I do it. I am able to decipher between the different languages. I don't know how I do it. Face recognition. I suppose a kid comes in and he or she resembles your neighbor. And you at once you will say, okay, are you his daughter or are you his son? You will say like this. But how? You don't know. You are able to decipher the faces. Whenever a newborn baby is born, you always say this, oh, he resembles his father, oh, he resembles his mother. How do you do that? It's a small child of just 2 days or 3 days. Then also you can say that, okay, he or she resembles his father or mother. And you can't explain how you do that. Eyes are same, nose is same, mouth is same, the forehead is same. What? On basis of what you say that? This is the face recognition. Image classification. There are so many breeds of dogs, but still you can find out, okay, this is a dog and it is not a cat. You will never get confused between a dog and a cat. Even though you have not seen this particular dog ever in your life. There are so many breeds and there are many possibilities that you have not seen that breed earlier. But still you can identify that this is a dog. And you will not say it is an elephant. Yes, you will never say it is an elephant, but you will definitely be able to identify that it is a dog, even though you have not seen it earlier. So this is image classification. You do it. You do it and you don't know how to do it. But if you want a machine to do it in the same way, tough time. Say, handwritten recognition. You are as in teachers, and we can understand any types of tools. This is also a tool. This is also a tool. This is also a tool, and you do it very professionally. You don't need any excuse for this, and you can do it. But if I want a machine to do it, it's a tough time. Recommendation system. So I'm just skipping this part because I need to talk about the 6 steps which are involved in machine learning. Define the objective, that is getting the T, gathering the data, preparation of the data. I showed you that COVID Excel sheet. It had all the countries. It had Australia, it has Argentina, it had USA, so many countries. I'm not concerned about all those countries. I'm more concerned about my country, India. So what did I do? I said Control F, India. Please mute your mic. So, first of all, gathering the data. I want to take as I told you, an example of taking the data from the students, for the students. So you have to retrieve the data from cities, states, universities, colleges, and country, and then only you can analyze it. So collection of data is not an easy task. Once you have the data, now you want to prepare the data. First of all, you got the data in different formats. So you have to convert them into a similar format, Excel sheet, or some any other format, SQL database, whatever. The format is not correct. Secondly, when I was trying to retrieve the data from Thrissur University, Thrissur College, some of the data was not available. So I'll have to get that data, or do the missing values need to be removed, or duplicate values need to be removed. And as I gave you an example of COVID, I said Control F India because I want the data only for my country. Then I moved a little forward because I wanted the dates from March. Till March, there were only 1 or 2 cases, so there is no point in analyzing it. Once the number of cases started increasing, I want to do the descriptive analysis of that. So the date needs to be changed, the country needs to be changed. So a lot of things needs to be done before applying an algorithm. That is all preparation of data. Exploration of data is what type of data do I have? What is the consistency between all the data? What is the relationship between all that type of data? That is exploration. And then I will build a model and do the evaluation and predict. As I told you, I want to predict what is going to, what is the number that is going to happen on 17th of September. That is prediction. So model evaluation is finding out P. What is my performance? As I told you, I am applying the data, I am applying an algorithm and saying that I got a data of 19,000 and actually it was 20,000. So what is the difference between the two? 1,000. So 1,000 upon 19,000 is my performance. Okay. So model evaluation is I'm trying to evaluate the model and what was the loss of 1,000. That is evaluation. So accordingly, I'll do some changes into this. I'll do some changes into the model so that I may get the least loss. I may get the loss as less as possible. Are the slides not visible? Sheetal is saying the slides are not visible. Okay, they are visible. Sheetal, and then I think you need to check it out. Ashok Kumar saying is not visible. They are visible or not? Some are saying visible, some are saying not visible. Oh. It's visible, not visible. Again, some of them are saying, if it is not visible, so please, what you can do is, either you can stop and then come back again. Let me share it again. I was at this point. Now is it visible? Okay, great. Thank you. So at any point of time, if you're not able to hear, see, please let me know. Because I will not be able to find it out what is happening. If you put in the chat box, then definitely I can take some measures. Great. So we were talking about this. Those who at what time it was not visible. Defining the objective is getting T. Data gathering is taking the data from different places. Preparation of the data, as I give you the examples of missing values or finding out for a particular country and so on. Exploring the data, finding out the hidden patterns. Building a model. Model evaluation is finding out the P. Data gathering is nothing but E. And then you predict it. What are the numbers on 17th of September? Something like that. That is prediction. So you do all these steps in this way. You gather the data. I must tell you one site which is kaggle.com. Kaggle. It's a very important website because it contains a lot of data sets. A lot of data sets. So if you want to work on eye, suppose retina images, so you will get the retina data set. If you want to work on brain images, CT scans, so you'll get a lot of CT scans there. Okay. So COVID data set is also available on Kaggle. In fact, I also took it from there only. So Kaggle is a very important website which will give you a lot of data set which you can use for your experiments. I'll now move on to the types of ML. Basically, there are three types: supervised, unsupervised, and reinforcement. These are the three types of learning. If I don't tell you anything, which type of learning is this? Can you guess? Just put it onto the chat box. Can you guess which type of learning is this? I got 9, 10, 11, 12. Anyone saying reinforcement? Is it reinforcement? Okay. So most of the people are saying supervised and unsupervised, and it's 50-50% in fact. Half of the people are saying supervised and half of the people are saying unsupervised. Two people have raised their hands. Manju ma'am, do you want to ask something? Manju ma'am, do you want to ask something? You have raised your hand. No? Okay. So, as the name suggests, supervised means there is someone to teach you. Like I am teaching you. I am telling you what is machine learning. I am telling you what is big data. I am telling you what is AI. I am telling you each and everything. This is supervised learning. So there is a teacher who is teaching the students. This is supervised learning. Okay. Now, once I have taught you, you were not able to understand what is data science. Okay, you were able to understand AI, you were able to understand some parts of it, but you were not able to understand what is data science. So what you did was you went on to Google and found out what is data science. So this is you combined your studies with my studies. I am teaching you. If you have understood everything, you don't have to do anything now. That is supervised learning. There was no webinar, there was no FDP, and you had to do everything on your own. There was no one to assist you. You didn't get any help from any of the faculty members, and you had to do everything on your own. That is unsupervised. This is unsupervised. You are studying on your own. You had to study everything on your own is unsupervised. And generally we combine these two and get a picture of semi-supervised. That is, I gave you an example. You were not able to understand data science, so you went again, checked on Google and find out what is data science. So that was a combination of supervised and unsupervised. So if the combination of the two techniques is used, it is known as semi-supervised. Okay, so you learn something in the class. That is what students also do. All your students do the same. But prior to this, if I talk about 20 years back when the internet was not so huge, so people were completely dependent on teachers. And the books were also not very much available. The libraries were not so efficient, and the books were not available in suppose if you see about a rural area, so the resources were not available. In those cases, you will say it was completely dependent on teachers. It was completely supervised. But nowadays, when internet is there, books are there, so much of things, so much of resource material is present. So you will say it is a semi-supervised technique. You do something on your own, you get the teaching from your teachers, and you combine the two. Correct? What is this? This is nothing but reinforcement learning. Reinforcement learning says you don't have any data. You don't have any data set. You don't have any database. As and when what you do, accordingly you get a feedback. Feedback from, as what, there's a small child and he's getting a feedback from his father. So if he gets 100 marks in his maths test, he says, very good, you have done very excellent. He will continue to do the same. He'll again study a lot and get 100 marks. Again, the father will say, perfect, you've done it well. Again, he will study and get 100 marks. Very good. So it will continue. Now, what if he put a hand in the button, in the switch, in the socket? He put her hands in the socket. He was trying to put the hand in the socket, and suddenly his father came in. What are you doing? You should not do this. And he scolds him. Okay. The father scolds him and says, you should not do this. So he will keep it in his mind that I should not put my hand in the socket. Correct? So he will learn this, that I should not put the hand in the socket, and next time I will not do it again. Correct? So now this is basically reinforcement learning. You don't have any data set. As and when what you do, you get a reward or a penalty. If it is a penalty, you will not repeat it again in the future. If it is a reward, you will do it again and again and again to get more rewards. Correct? So currently, most of the games are made using reinforcement learning because you don't have any data set, and as and when you proceed, your data set is made. What is that data set? The set of experiences that you gain. What was the experience? I should not put a hand in the socket. I should study well so that I get 100 marks, like this. So these are the experiences that you keep it in your mind, you store it into your database, and accordingly you work. Okay? So you get a picture of how you are supposed to actually handle the things. That is, as and when you get some things and your database is created accordingly. Alphago is a game again, which, and as I told you, most of the games use reinforcement learning. So that is also using deep learning and a reinforcement learning both. So supervised learning is also known as a learning method which uses labeled data. Now, what is the meaning of labeled data? Let me give you an idea. Suppose I have this data. I have such types of data. Okay. So what will I do is, in this case, it's mentioned. In this case, it is mentioned that this is a square. This is a square. This is a circle. A circle. A circle. A square. So I have been given a data and I have properly labeled the data also. So what will it do? It will combine these two. It will compare this with this because these two are squares. So it will find out its features. Now features is an important word because in all the machine learning algorithms you will do this. Feature extraction. Features are things, properties that make it different from the rest. Okay. So you find out what is common between these two. What is common? It has 4 sides, red in color, 4 angles, all sides equal. So it gets 4 features for this. There are 4 sides, all are equal, red in color, and it has 4 angles. Correct? So what will it do? Anything which has the same features, like this and this, it will put inside one set and term the set as squares. Any shape, any data, any input data which has the same features like this, 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 and this, it has the same features of 4 sides, red in color, all sides are equal, it will put it inside one set. Then it will try to find out between this and this because they have the same label. So it will compare these two and say, okay, it doesn't have any sides, it doesn't have any angles, it is round in shape and purple in color. So it will take all this and put it inside another set and term it as circle because they had the similar features. This is nothing but supervised learning. Why is it known as supervised learning? Because you knew that this is a square and this is a circle. Proper labels were given. But you do feature extraction, you do all the processing so that you can get it inside one set. Correct? Now, there is another thing and says that, okay, the labels are not mentioned. The labels are not mentioned. If the labels are not mentioned, so how it is going to do? It will take this and this, or it will take this and this also, and find out the similarity measures. It will combine these two, it will test these two and say, are they equal? This has 4 square, this has 4 lines, it is red in color. This doesn't have any lines, it is not red in color. So it will say, no, these two don't resemble. Then it will compare this with this and say, okay, yes, it has common features. They are both red in color. It has 4 sides and all are equal. So probably these two belong to the same set. And it will put it inside one set. It doesn't know what is the name of the set. So it will simply say it is A. Okay. Similarly, it will combine these two and say, okay, they have the same features, but it is different from this feature. The feature of a circle purple figure is different from the features of red figure. So it will put all the purple figures in one box and say, okay, this is B. Okay. So it has made 2 sets of A and B having members of the same type, some data, but it doesn't know what is the name of this. This is nothing but unsupervised cluster. Because the data was not labeled, you didn't know that it is a square or it is a circle, and by just feature matching, extraction of features and matching the features, you were able to do it. Correct? So let's get back to the example. This is an example in which you have a lot of images of Tom and Jerry. Okay. Now Tom is labeled. You have labeled data, but the feature extraction will happen. You will find out, okay, it has a long body, it has a tail, it has 2 hands, 2 legs, pink ears, and so on. This also are of the same features. This is also of the same feature. So why not put it inside one set and term it as Tom? This and then this 3 have the same set of features. It is small in body, brown in color, and small hair, and small tail, and so on. So why not combine this 2 and put it inside one set and make it as Jerry? Okay. So you will perform these 6 steps which are discussed in machine learning. The 6 steps will always be there. Data cleaning, exploratory data analysis, algorithm model evaluations. All the steps will remain the same. So if somebody asks you that what is the difference between the steps involved, you will say both are same. It's only depending on the data you have. If the data is labeled, you will say it is supervised learning. If the data is not labeled, you will say it is unsupervised learning. So always keep this in mind. Always. If the data is labeled, you will apply supervised learning techniques. If the data is not labeled, you will apply unsupervised techniques. But generally what happens is, you have the data, you have this data, some of the data is labeled, some of the data is labeled, and some of the data is not labeled. So if you see, only 3 of these are labeled and the rest of them are not labeled. So you have to apply a semi-supervised technique to handle the labeled and the unlabeled data. To handle the labeled data, you will use supervised technique. For unlabeled data, you will use unsupervised technique. So generally we go for a semi-supervised technique. So most of the techniques that exist are now advanced, quite advanced to a little bit, and you are able to apply it on any type of data which is a mix of them. So you go for a semi-supervised technique. Okay. So this is supervised learning. Supervised learning is of 2 types: continuous target variable and categorical target variable. There are 2 types of variables. Continuous variables are those variables which take on a graph value, something like this. This is a continuous value. For every x, you will have a y. So this is a continuous value. For every x, you will have a y. So you have some equations like y is equal to mx plus c, something like that. I skipped that part of dependent and independent variables and continuous and fixed speed because of the shortage of time. X is a independent variable and y is a dependent variable because y is depending on the values of mx and c. So y is considered to be a dependent variable, and x is considered to be an independent variable. So if it is a continuous value, it is known as continuous. If the output is my continuous value, then we go for regression technique. And if it is a categorical target variable, like these are the points, in such cases we go for classification. As an example of Tom and Jerry, that is a classification example, because there was no continuous value. If we are trying to predict the stock market, it is a continuous value. Today it is something, tomorrow it is something, tomorrow it is something, and they are dependent on each other. Yesterday what was the value, today what is the value, it is dependent on each other. That is regression. Classification is there is no dependency and there is no continuous value, then that is classification. Am I audible? Akhilesh sir is saying that I am not audible. Okay. Akhilesh sir, then you need to check at your end. It is audible. Unsupervised learning, as I told you, it doesn't have any labels. So you will put it inside one set and say it is one set, and then you put it into another set, and this you say it is another set. Yes, and this question. Okay. Sakshi ma'am, regression is a complete altogether different session. So probably tomorrow I think you have a session on regression. You will get that. It is basically if you have a continuous value like this and you want to predict, suppose this is my x, and you want to correspondingly predict the value of y for it. This is my x, this is y for it. This is regression. You will have that. Abhishek sir, I have already explained supervised learning in that you don't have the labeled, you have the labeled data, and on the basis of the labels you decide, and on the base that what is the name of that particular cluster. Okay. So we have a regression and classification on that. Regression goes for continuous values, and classification goes for discrete values. If you have discrete values, you go for classification. Jitin sir, yes, classification goes for yes/no values also. That logistic regression is one type of that. Logistic regression. Please mute your mic, please. Abdul Rashid sir. Logistic regression is a binary classifier which gives you yes or no. Please mute your mic.
Oh yeah.
It really becomes very tough. There is a background sound. Please mute your mic. Okay. So as I was telling you that if it is a continuous value, still there is a sound. Please mute your mic. Biju sir, I would really request you to please mute all. Biju sir, please mute all. I cannot do it at my end. So if you have a graph like this, for every x you have a y. This is a continuous value. And discrete value is like this. So you put this inside one set, you put this inside another set, whatever. This is classification problem. It is a discrete value. Unsupervised learning, I'll go back to this. Unsupervised learning are it's basically of two types, clustering and association. This is something, clustering is different and association is different. When the target variable is not available, And clustering can be divided into three types: partitioning, hierarchical, and density. So partitioning clustering, in which you use Sting, Clarence, and K-Meteor's algorithms. Hierarchical clustering is very important, in which we go for agglomerative clustering and divisive clustering and so on. And for the particular algorithms that we use. Still there is a noise. And for density-based clustering algorithms, we use DBSCAN, Denkul, Optic. These are three algorithms that we generally use. For hierarchical, we use such types of algorithms, and for partitioning, we use these types of algorithms. K means clustering goes inside partitioning. Okay? So, in short, if you have a continuous variable and you want to have a labeled data, I have a labeled data and it is a continuous variable. So we use regression. I have a labeled, if I have a continuous value but it is not labeled, we'll go for dimensionality reduction. I have a labeled data and discrete values, we'll go for classification. I have an unlabeled data with discrete values, we go for clustering. I'm again repeating. If I have a labeled data with continuous values, we go for regression. I have a labeled data and discrete values, we'll go for classification. I have an unlabeled data and discrete values, we go for clustering. I have an unlabeled data with continuous values, we go for dimensionality reduction. So with the type of data you decide, as I was telling you about ML, data gathering and preparation. This is a very, very important step, in fact, nowadays. Because applying an algorithm is easy. It is a 4-line code. That's it. I showed you the code also, in fact. It's a 4-line code. So applying a model, evaluating it is fairly easy. The main important part is data gathering and preparation. Take the data and prepare it. And according to the data, you decide that which type of approach you are going to apply. If the data is labeled, non-labeled, categorical, continuous, and accordingly you are going to apply which algorithm. Okay? Next, coming to reinforcement, I have already given you an example, and it is generally used in those environments in which you don't have enough data and you mainly depend on the feedback from the environment. So you do some observations, you do an action, agent does an action on the environment. Environment gives you the feedback in the form of an observation. Either it is a reward or a penalty, and accordingly the agent will store that data. Agent is nothing but a reinforcement learning agent. So this is the way how you do it, and generally the feedback is given by a human expert. So you do something, you can put a query also to that human expert and you get a response. You do something, you perform certain action and you get a feedback in the form of perception. And the same perception is forward to the human expert and it will tell you, okay, this is right or wrong. That is, you wanted a reward or you wanted a penalty for it. So inventory management, and in many of the cases, these reinforcement learning tools are being used. This is an example of a reinforcement learning robot, which is trying to do some industrial application based on its feedback. Because in the case of industrial applications, you cannot train the machine for everything. So as and when you experience, you gain the data. That approximately finishes off my presentation. So if you have any doubts or questions, I would love to take that, because I need to break at 12:45. So we can have the question answers in another 5 minutes. Step 2 of machine learning.
Ma'am, what do you mean by dimensionality reduction?
Again, these are the questions. These are different algorithms on which you work. it's not possible to cover everything here. Dimensionality reduction basically deals with if you have a huge dimensions of data. It's in 4 dimensions. So how to reduce the dimensions, and we use a very important algorithm of PCA, principal component analysis. Classification and regression, Revati ma'am, as I've already told you, classification is a problem of supervised learning. Regression is also a problem of supervised learning. But regression is for continuous data and classification is for Harmeet ma'am, reinforcement learning always deal with rewards. As I give you an example, there is a small child. If he does something correctly, he'll get a reward. If he doesn't do it correctly, he will get a penalty. So this reward and penalty either can be given by the environment or by a human expert, as what we discussed. No, Jitin sir, programming example will not be possible in this session. You would be getting those hands-on sessions in the due course of time, and you will get that. Regarding somebody asked me about this, so I'm explaining it again. First of all, you will take the data from different sources, how you gather the data, and then you would like to prepare the data in a format so that you can actually use it. So as I told you, Kaggle is one of the sites from which you can take the data, MNIST and CIFAR 10 and another sites from which you can take the data. And then if suppose I have an Excel sheet like this. Okay, I have an Excel sheet and the value of this was 1, 2, and this value was missing. So what I can do is I can take an average of these two. 1, 2 is 1.5 and I can replace this blank with 1.5. So this is taking care of the missing values. Duplicate values can be taken care of and so on. SVM is support vector machine. Don't be in a hurry. Everything would be covered. Don't worry. It's just the first day. You have another 4 days of your workshop. All the things would be covered. SVM probably you would covered in the due course of time. SVM is a semi-supervised learning technique which is able to handle both labeled and unlabeled data. It's a support vector machine. Categorical data is, as I told you about Tom and Jerry wala part. This is categorical data. This is a categorical data because it doesn't have a continuous value. This is Tom, this is Jerry, this is categorical data. Deep learning is used in those cases in which you can apply a more sophisticated algorithm. See, deep learning always deals with artificial neural networks, ANN. Artificial neural networks. What is ANN is basically when you want to replicate your as what a human brain works, we want machine also to behave in the same way. So I'm replicating a human brain. Correct. So when I'm doing that, I have neurons, I have perceptrons, I have everything. This is nothing but ANN. ANN with one layer is ANN. ANN with more than one layer is deep learning. In simple layman terms. So if you increase the number of layers, it becomes convolution neural network, or you can say it is deep learning. Okay, what is SVM? Clustering is used if you have a categorical data and a non-labeled data. IoT sensor data, it depends. Generally, IoT sensor data is a non-labeled data and you apply clustering onto it. Correct? But if it is labeled data and a continuous, and generally sensor data is a categorical data, continuous data. Generally, IoT data is a continuous data. If I have shown you this now, so keep track of this. IoT sensor data is a non-labeled, so I'll move on this part, and it's a continuous data. So we'll go on for dimensionality reduction first. There is no fixed number of hidden layers, Sneha Bora ma'am. It can have any number of layers. So as and when you increase the number of layers, it will become more deep, 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 and deep. Okay. Sonal ma'am, I've already mentioned I'll share all the slides, all the materials with Biju sir, and he would share it with you all. Jitin sir, I think you were not there at the time of when I was telling about the difference between AI and ML. Whatever you do in ML is AI. So whatever we have discussed till here is all AI. You mentioned clustering as unsupervised, but in K-means we have known labels and hence it needs to be considered as supervised algorithm. Yes, yes. K-means is a classification technique also and a clustering technique also. So as I have already mentioned, you don't get confused on the type of technique. It will be always based on the type of data you have. If the data is labeled, you will go for a supervised technique. If the data is not labeled, you will go for a unsupervised techniques. And all these techniques of SVM, K-means, KNN, these are all semi-supervised. So you would not say it is supervised or not. In fact, if you search on Google, you will get various answers on this. And they all will be very confusing. So don't get confused at all. You just stick to the basics. Whether the data is labeled or not labeled. Whether the value is categorical or continuous. Thank you, Shrija ma'am. Thank you, Neeta Bhatt ma'am, so much. Thank you so much. Bisaki Jana, thank you so much. RNN is a type of recurrent neural network which comes inside deep learning. It's another type of ANN, recurrent neural network. RNN is generally used in NLP applications when you have a sequence of data. When you get sequence of data, you use recurrent neural networks. Got it? Any other questions? Thank you, Pranay sir. Thank you, Shailja ma'am, Hemant sir. Thank you so much. Thank you, Anirudh Kumar. Thank you so much. Thank you. Biju sir, I think I am done.
Yeah, you done everything very well, ma'am.
Thank you.
I hope all the participants enjoyed the session very well from their feedback in the chat box. And thank you for this wonderful session for our participants through the ATAL FDP as the introductory session. Dear participants, I think you also enjoyed the session very well. And unfortunately, the Pooja ma'am is busy with other schedule. That's why she is not available for the further session. So I think she can join on Friday for some session. And depending on her busy schedule, we will decide on this day. Sometimes Pooja ma'am will conduct one more session in the Friday afternoon. So far, thank you, ma'am. We will see again, and thanks for you for all the participants in this FDP. Okay, thank you, ma'am.
Thank you so much. Somebody is asking for the contact.
Dear participants, the second session will start by 1:45 itself. Now it is 12:50. We lost half an hour due to the network issues in the inaugural session. Anyway, we will start the second session, hands-on session, in 1:45 itself. Dr. Ravi Kumar is presenting for you during the session, and you are requested to open with your laptop and then internet connectivity. Means other softwares are already installed. I think that is available in your machine itself. So there is no need to install anything special. Mr. Ravi Kumar will share you the steps to install in some little softwares during the training program. So please join by 1:45 itself. That's one thing. The second thing is somebody has not entered the attendance in the Google form so far. So I had activated the Google form during this Pooja Madam's session, but only 116 participants were marked the attendance. So please mark your attendance now itself. It is again activated now. So you can enter your attendance in 15 minutes. Then after that you can go for the lunch and join by 1:45 through the same meeting code. Thank you. If participants, do you want to share anything to the host?
So just one thing from my side, I forgot to mention my details. I have mentioned my email ID as iitngpcsc@gmail.com. So at any point of time, if you face any problems in any of the algorithms, if you want assistance regarding projects, research projects, or something like that, you just let me know. I would love to help you out. So be in touch, keep home, keep safe, keep yourself safe from coronavirus, and keep your family also safe from that. Thank you so much. Thank you, Biju sir, for giving this opportunity. Thank you so much.